Check. So, students online, can you hear me clearly? Can you hear me clearly? Please confirm. Please confirm with a message in the YouTube live chat and the Zoom chat. Okay. Okay. So then let's start the session. So I think students are still joining, but let's anyways continue. So the plan is, towards the middle of the session, I'll again explain the plan because students are still joining to the session. Today we are starting the fast track program for 28 batch. Why do we call this the fast track? We have our usual Tuesday evening English medium class. It's going to continue as usual. And parallel to that, we are doing this to cover a separate series of lessons, okay? Parallel to that, we are doing this to cover a separate series of lessons. So with the main class on Tuesday evenings and with this fast track program together, our plan is to maybe finish the syllabus like 1 year before the exam. Then there will be a full syllabus paper program available for the whole year. So if anyone follows this fast track program, the plan would be like you'll be done with the syllabus maybe 1 year before the exam. Then you can write full syllabus papers for 1 whole year before the exam. So I mean, it would have an extreme advantage over others, okay? But at the same time, I have to tell, this is not mandatory for anyone, okay? You don't have to join to this, okay? This is not mandatory for anyone, because anyways, in the main class, we are going to do these lessons again, okay? For the main class students, we are going to do these lessons again. So the thing is, so this is something additional. If you like, you can continue. Then you will be able to finish the syllabus maybe 1 year before the exam. But if not, you can continue the normal classes on Tuesday evenings, okay? If not, you can continue the Tuesday classes on normal Tuesday evening class. Then the syllabus will be done maybe like 6 months before the exams, as we usually do, okay? So that is the idea. So this is not a mandatory session for anyone. This is an additional fast track program that goes parallel to our main classes happening on Tuesday evening. So the programs happening now in the class is Tuesday evening, you have from 3 to 6:30 the normal class, 6:30 to 7:30 the additional Olympiad question discussion, and the fast track program on Monday nights, 8:30 to 10:30. And at the same time, you have the weekly paper. Now we have started, okay? Now we have started the weekly paper. Weekly paper writing time slots are available in the groups. You can join the weekly paper parallel to all the classes, okay? So again, there was a question. No, there are no additional charges. All these programs are a part of the main class, okay? All these programs are a part of the main class. So there are no additional charges or anything like that. Like you just have to continue the sessions you like. So the only mandatory thing is the Tuesday evening normal class, where we have started mechanics now, right? We have started mechanics now. So only mandatory class, the class you must come is the Tuesday evening class. All other stuff are additional. If you like, you can join the fast track. If you like, you can write the weekly paper like that. All other additional stuff. If you like, you can continue. Otherwise, you can go in the normal program on Tuesday evenings, okay? So for any issues you are facing, if you are not in the group, or if you are new and need to join the class, or any issue, just contact this number for tooth related issues, okay? For tooth related issues or anything else, okay? For tooth related issues or anything else, just contact this number. Contact this number, put a message to WhatsApp message to this number, or give a call to this number to be added to the group, to join the classes, to get the recordings you have missed, to clarify any tooth related issues. For anything, contact this number. And the thing is, I think we distributed the optics tooths to the whole physical class, right? And for anyone who requested for the mechanics tooths, that means the vectors tooth, we send the optics tooth with that. So any student who was joining the class, okay, Any student who kept joining the main class must have the optics tute. And there's a question, can we join physically? Yes, I'm doing this at Sysygy. Okay, I'm doing this at Sysygy. So yes, if you like, you can join physically at Nugegoda, Sysygy. There's currently some people here, like I don't know why are they here, but yes. So, and maybe if required, I can shift this to 8 or something like that, but I'm not sure whether it's a convenient time or not. I don't think so, right? You have classes before this. I don't know. We have to discuss about that. If required, we can shift this to maybe to 8 or something like that. Or like change in the date and anything is possible because this is a very night time. So I don't think you have classes at 8:30, 10:30 time slot on any other day. So based on your requirements, maybe change in the date or shift in the time a bit. It's not a, it's possible, okay? It's possible. You just have to let me know in the main class, okay? In the main classes, we'll discuss about this. Then in the main classes, you can inform me about any requirement of a change of time or change of date. Yes, we can discuss about that in the main class. For now, let's start here and continue. Okay, let's discuss all other issues in the main class. Okay, yeah, just let me know. And yes, you can join physically if you like. Okay. Yes, use a separate book for optics. Use a separate book for optics. And yes, if you want, like you can join the optics session happening this year. And again, if you like, if there's a tendency to forget things, when we are doing optics again in the next year for 28 batch without the fast track as the normal program, you can join that too, okay? You can join both if you like, okay? So, yes, maybe maintain a separate book, okay? Separate book. Okay, so the lesson optics. Lesson optics. So towards the end of the class, I'll explain the plan again, okay? For light, we have to start with the topic light. Okay. So what is light? Like a certain part of this lesson. A certain part of this lesson was there in your O-level, okay? It was there in your O-level book, and the tutors are available in the drive link. And for all the class students, we have like delivered the tutors. If not, we'll deliver them soon. Okay. So light is just a type of wave. So there are several types of waves, right? There are several types of waves, such like sound waves, heat waves, optical waves, radio waves, TV communication kind of stuff, Wi-Fi. This is actually a wave, okay? Wi-Fi is a wave with a certain frequency. All radio channels have frequencies. Why? These are waves. So majority of the things that we use for communication today are waves, right? And what is this light or optics? It is the range of waves. You know that all the waves have certain frequencies and wavelengths, right? From all of us, you know these things, right? The range of wavelengths where our eyes are sensitive. Okay? The range of wavelengths where our eyes are sensitive, we call that light. Okay? So you have to correct this in the book. Okay? It should not be millimeters. It should be from 380 nanometers to 780 nanometers. Okay? 380 nanometers to 780 nanometers. Okay? 380 nanometers to 780 nanometers. This range, it's not milli, it should be nano. This range of wavelengths, okay? This range of wavelengths, our eyes are sensitive to these waves. That range we call light, okay? So, how do we mark a ray of light? How do we mark a ray of light? And at the same time, some students requested for paper centers. Yes, so the paper centers would be starting very soon in Gampaha. I can't remember, there was a series of paper centers. Okay, so we'll provide all the information in the group. Okay, so for weekly paper, yes, the paper centers will be available within like 2-3 weeks. the paper centers will be available, so you can write the paper physically if you like. So this is a ray of light. This is how we mark a ray of light with an arrow. Okay. So this is very important. It looks like a vector, right? Looks like a vector. So the arrow should show the direction. Arrow should show the direction. That is the idea. And at the same time, you have to make sure that this is a rule. Okay, this is a rule. So you have to make sure that you are putting this arrow. That means this is just a line. This is just a line, and this is an arrow. Okay, clear? That means this comes very later. Assume you have a convex lens, concave lens, some kind of a setup, then maybe a mirror after that. So a ray goes like this, then like this, then like this, then reflect back like this. Okay, ray goes in a path like this. Okay. If a ray goes in a path like this, and you definitely have to draw these kind of stuff. Let's talk about that later. You won't get any marks for this diagram, okay? You won't get any marks for this diagram. Why? What is the reason? What is the reason? You won't get any marks for this diagram because in this part, you don't have that arrow, okay? You don't have this head, okay? In this part. This is just a line. This is just a line. This is an optical ray. Okay. This is just a line and this is an optical ray. So it's entirely different. Okay. So in a ray diagram, if you forget to put the head somewhere, okay. If you forget to put the head somewhere, it is like optical ray have reached here, then suddenly disappeared, then started from here. Okay, so it's out of rules then. Okay, clear? So have to make sure that you follow the proper notation whenever you are working with optical rays. Okay, then talking about a bunch of optical rays. Okay, online students use this number for any information. Okay, then if we use optical rays, okay, if we use a bunch of optical rays, a bunch of rays we call a beam, okay, a bunch of rays we call a beam, okay. That means this is a bunch of optical rays, okay, this is a bunch of optical rays and we call this a beam, and this is a parallel beam. This is a parallel beam of light. Okay. This kind of a beam we'll call a convergent beam of light. It's converging. Clear? Then this kind of a one we call a diverging. Okay. A diverging beam. Okay. Clear? So there are different types of optical beams. So we haven't started the proper lesson yet. We are just going through the terms. We have to know the sign conventions, the way how to draw things. We are just learning these things at the moment. Then another thing like that, we have to discuss a bit about sources of light. Okay, we have to discuss a bit about sources of light. Okay, what are sources of light? Sources of light means there are two types of sources of light, primary and secondary. Primary sources and secondary sources. Secondary sources are not actual sources, okay? Secondary sources are not actual sources. Only primary sources can be considered as a source of light. That means, for an example, this light. For an example, this light or sun. They actually produce optical energy, okay? They actually produce optical energy. That kind of a thing we call a primary source, okay? Or just a source. All other, how can we see this pen? How can we see this pen? Rays reach the pen and reflect back, okay? Rays reach the pen and reflect back. That's how we see this pen, okay? Clear? So these are secondary sources. Everything around us, everything we can see act as secondary sources which are not actual sources, okay? They just reflect whatever the light they get. As a result, we can see them, okay? As a result, we can see them. Got the idea? Okay, that's how it works. So here it is sources of light, okay? Next, moving forward. Then we have to classify the media, okay? We have to classify the medium. You have transparent medium. What is that? What is a transparent medium? A transparent medium is a medium which allows optical rays to move through that easily. Okay? A transparent medium is a medium which it allows optical rays to pass through it easily. Okay? Clear? Then you have, this is transparent, okay? This is transparent. Then you have translucent medium. What is a translucent medium? This is transparent. What is a translucent medium? It allows a certain amount of light, but not a very good clarity. This is just a glass panel or a window. You can see everything, right? You can see everything. But you have seen some windows, they just allow light, but you can't see through properly, right? Or glass blocks that they use for construction. So the glass blocks that they use for construction, it lets some light in. Okay? It lets some light in, but not very clearly. Even a polythene sheet, you would get some light in, but you won't see through, right? That is a translucent medium. Then you have opaque medium. What are they? It doesn't allow any light to pass through. For an example, concrete, okay? Opaque medium means it won't allow any light to pass through it, okay? Clear? It won't allow any light to pass through it. Got the idea? So that's about the terms, okay? That's all. That's about the terms. So these stuff are not actually in the syllabus, but I mean, you have to have a certain idea, okay? You have to have a certain idea about these terms. Then comes reflection. So in this lesson, it just starts with the properties of light. We learn what is light, then we start learning the properties of light, okay? So when we discuss about the properties of light, we have reflection, refraction kind of stuff, right? So we start with reflection, but in the teacher's guide, they haven't asked us to teach reflection, okay? In the teacher's guide, they haven't asked us to teach reflection. So it's basically not in the syllabus, but they can ask plenty of questions and they keep asking why. The assumption is you're okay with reflection because you had that in O levels, okay? The assumption is you should be okay with reflection questions. You don't have to teach that in A levels. Students anyways learn that in O levels. So that knowledge is sufficient. So that is the idea about reflection. But I usually teach it not to a very great extent, okay? I'm not gonna explain everything, then start from easier questions to go to difficult questions. There's a way that we usually teach. I'm not gonna do that project with reflection. Why? It's not in the teacher's guide, so we shouldn't waste a lot of time on that. So what I'm gonna do is I'm gonna quickly remind you the theory. Then we are going to do like 3-4 very difficult questions. Why? I'll show you how to use your O-level knowledge to handle a A-level maybe a very difficult question, okay? That is the idea. So I'm going to quickly go through reflection, but would definitely take some time today for that, but not up to an extent that I usually teach a lesson because it is not in the teacher's guide, okay? So, So let's start with the first property, reflection. And students, you have to set up the Sysygy websites, okay? To keep joining all the sessions, you have to set up the Sysygy website. So all the information will be available in the group. The students who are physically coming, they can directly access the website. They get direct access to their account on the website, sysygy.lk, as I remember. And the students who are joining entirely online, they have to join to the sysygyonline.lk, as I remember. Through that, you can join the sessions. Just contact this number and join the group. Then you would get all the information required, and we'll post all these website information, how to access that and everything. We'll post in the group, okay? So even the physical students, that means the entire physical students, that means I think there are students like you guys, I mean, who join all the sessions physically, never go to the website. There are people like that, right? Even them set up the website. Why? That's the main reason you are not watching recordings if you miss a session. You always postpone setting up the website, so have no idea how to go to the website. So you never access a recording, so you keep like missing stuff, right? So definitely everyone set up the website, because you have to join all the upcoming sessions through the website. For physical students, there's a website. For entirely online students, there's a separate website. All have the same functionalities. To get the paper reviews, paper discussions, you may have to use the website, because we can't put everything in the group. Already the group looks like a bunch of, it's a huge notice board, right? On any given day, if you go to the group, it have like 50 unread messages, right? So already the group isn't gonna work properly. So definitely you have to set up the website. Then you can access the weekly paper, access the marking, access the paper discussions, access the missed recordings, access if one day if you are not able to join physically, you can join online the same day without any issue. And you can keep joining the optics sessions, and there would be some optics question discussion sessions. So things would happen through the website. So definitely set up the website, okay? We'll provide all the information. So now it's not like you have to create a website, okay? You just have to go to the website, which you are not gonna do, okay? So moving forward, reflection, you have a good clarity about reflection, okay? What is reflection? Reflection is there's a boundary where this boundary separates two sides, and optical energy reach this boundary and bounce back. Optical energy reach this boundary, okay? Optical energy reach this boundary and bounce back, okay? Clear? Optical energy reach this boundary and bounce back again, clear? This we call reflection, okay? If it falls to the other side, we call it a name. What is that? If it falls to the other side, we give it a name, refraction. Let's talk about that later. That is in the syllabus, okay? That is, actually the optics lesson in the syllabus starts with refraction, okay? Clear? So, but let's discuss reflection. Reflection follows two laws. What are they? Reflection follows two laws. What are they? Two reflection laws. This incident ray, reflected ray, and this perpendicular line drawn to this point. Everything is on the same plane, okay? Everything is on the same plane. This ray, this one, and this one, everything is on the same plane, okay? Clear? Everything is on the same plane. And the other one is the angle between the incident ray and the perpendicular line. We call this the incident angle is equal to the reflected angle. These two you learnt in O levels, right? Equal to the reflected angle. Then at the same time, due to this behavior, due to these two rules, in O levels, you learn the behavior of a mirror, right? You learn the behavior of a mirror. So is it clear, these two rules? It's clear, right? So due to these two rules, if this is a mirror, what is a mirror? A very good reflecting setup, right? Mirror is a very good reflecting setup. If you place an object somewhere like this, if you place an object somewhere like this, its rays are gonna go like this, then reflect back. Its rays would go like this and reflect back. Okay? Since it falls with 0 angle, it's going to reflect back with 0 angle, right? Since it falls with angle 0, it's going to reflect with angle 0. Then for the next one, it's going to go like this. If the incident angle is theta, it's going to reflect back with the same angle. It's going to reflect back with the same angle theta. Now you are here. You have your eyes here. Okay. So now when you are here at a distance like this from the mirror, this ray which returns reach your eye, right? This ray which returns reach your eye. Clear? This ray which returns reach your eye, and this ray again reach your eye. Now what your brain does is, using the rays it received, it's gonna create an image. It's gonna see an image, right? Based on the rays it received, the brain and the eyes don't know the story. That light started here, went, reflected back. We don't know that story. So as a result, the brain and the eyes together, what they are going to do is, they are going to create a point based on these rays, right? So when the brain and the eyes trace this back, when the brain and the eyes trace this back like this, okay, it's gonna see the image here. Got the idea? They're gonna see the image here. There's no actual image here, okay? There's no actual image here. If you go behind the mirror and look, there's nothing, right? There's nothing. There's no actual image here. It's just what we see based on what we receive. Okay, it's just something we see based on what we receive into our eye. Okay, so we call this kind of image, in O levels you gave it a name, a virtual image. Did you have that term? Yes, right? Term virtual image. So this kind of image we call a virtual image. Such image it's not actually there. It just looks like it's there. Okay. So that's how a mirror works, okay? That's how a mirror works. And at the same time, if you see, if this angle is theta, this is also theta, right? If this angle is theta, this is also theta, clear? If this is theta, this is theta. Then this line is common for both this triangle and this triangle. This is 90 and this is 90. I can't remember, but this information is more than sufficient to tell that these two triangles are same, right? Clear? These two triangles are same. You had rules in O levels for this, I don't care. I mean, it just looks like they are equal, right? And they are actually equal, right? Out from all the aspects, these two triangles are equal. So that means this point, the distance to the object from the mirror will be equal to the distance to the image from the mirror. Clear? So for any image, for any mirror image, distance to the object from the mirror would be equal to the distance to the image from the mirror. Clear? So distance to the object equals distance to the image. Okay. So due to this reason, that's why you get an inversion. That's why you get an inversion when looking through a mirror, right? Clear? That's why things invert. That's why things invert when looked through the mirror. Why? For an example, let's assume that we have letter B. We have letter B in front of the mirror like this. So for this point, the distance is x, right? So that point will be recreated at a similar distance. That point will be recreated at a similar distance. Then this point is at a distance y. This point is at a distance y. Okay. Then that point will be recreated here. That point will be recreated here. Clear? This point will be recreated here, right? Distance to this point is y, so it's going to be similar. Clear? So the image will be created like this. See, there's an inversion. Clear? There's an inversion due to this reason through a mirror. Okay? Through a mirror, there would be an inversion always. So that's all. When it comes to reflection, that's all you have to learn. Okay? Clear? That's all you have to learn about reflection. There's nothing more. Okay? Even in O levels, you learn these things. So based on these, they can ask any difficult question. Okay? That is the thing. Based on this, they can ask any difficult question. So let's go do some questions. Questions are towards the end of the tute. And we actually forgot to put the page number, so we are in trouble actually. What actually happened was I removed a large part of the tute, okay? I removed a large part of the tute. The reason is, in optics, you have to remember the ray diagrams. You have to draw them yourselves. And in my tutes, I usually put all the theory, right? We put all the theory in my tutes. We don't keep anything for you to write. So previous years, what I usually do is, I keep them in the tute, but I ask you to draw anyways, but you are never going to do that properly. So this time we removed all the diagrams from the tute and we are going to draw them, okay? Because if you forget to draw these things, if you don't do this at least once, then you are not going to remember the things on the day of A levels, okay? So all the ray diagrams I removed from the book and we have to draw them, okay? So after doing that, we actually forgot to put the page numbers and all back. So as a result, we don't have page numbers. So go to the end of the tute. Towards the end of the tute, you can find exercises. You have to somehow find exercise 1. You have to somehow find exercise 1. Do questions in this order, okay? Question 3. Question 2, 4 and 1. Do questions in this order of exercise 1. Questions will be difficult because as I said, I'm not going to go through the normal process to teach this part. It's not in the teacher's guide. So we are going to show you how difficult can questions be and how to handle them and move forward with what we actually have in the syllabus. Okay. So towards the end of the tute, you can find exercises. Post if you have any questions, okay? Post if you have any questions. So you may not be able to handle some questions, no worries about that. I'll explain you how to use what you already know to handle these questions. Towards the end of the tute, you can find the exercises 3, 2, 4, and 1 of exercise 1. Do questions in this order, okay? If you have any questions, put a message. I'll provide the tute links again. Tutes are tutes are available. You can get it from the drive link, okay? You can get the tutes from the drive link. But anyways, the tutes are like, we actually delivered all the tutes for the students who required, okay? I think close to more than 1,000 tutes we delivered, so ideally everyone should have received the tutes by now. Just pause if you have any questions. The third question isn't that difficult, okay? You can quickly finish that and move forward to 2, 4, and 1. So some students said that your schools are starting right now. Before August, had schools today. Okay. So we might have to maybe work on the class time a bit, maybe, right? We'll discuss that on Tuesday. So have usually, I mean, now they started teaching. Okay. You have bigger problems, right? So some schools have started by now. So I mean, it's pointless. We have to give holidays again in August for A-levels for 1 month. But anyway, some schools have started. Next week we have unit tests at school. Some schools are starting on 16th. Others just put a message on what is happening actually. In September. So in some schools they have finished the vernier caliper. So started today. I don't think that you have to worry about attendance these days, right? Because I mean, still students are shifting the schools, right? So I mean, if they start counting 80% now, the new students would anyway start with a loss of 10% or something like that. So just let me know about the class time, okay? If there's a requirement to shift the class time, maybe delay the class time by at least maybe 15 minutes or something like that. So the physical students can come and the online students can go to home before the class time. So just concerns like that, put in the chat, okay? Based on that, I can decide whether to shift the class time, move the class time down by maybe 15 minutes or 20 minutes or something like that. It entirely depends on your requirement. So you have to mention. So the first question, if I start with the third question number 3, it's not that difficult. So within this week, before the next week's session, please set up the website, okay? Everyone, please set up the website. We'll provide all the information in the group. If you're not in the groups, join the groups. Question 3 isn't that difficult. An object is placed between two parallel plane mirrors. There are two parallel plane mirrors. Two parallel mirrors like this, okay? Then facing each other 20 centimeter apart. Facing each other 20 centimeter apart. 20 centimeter apart. Okay. Then 8 centimeter from one of the mirrors. At a distance of 8 centimeters from one of the mirrors. Okay. Calculate the distance from the object to the first two images. I'll just find the location of first two images. So this is one mirror. Okay. This is one mirror and this is the other mirror. This is the other mirror. If the distance to the object is 8 centimeters, distance to the image would be again 8 centimeters. Okay. If the distance to the object is 8 centimeters, here distance to the image would be 8 centimeters. Then here to the other mirror, if this is 20 and this is 8, this would be 12 centimeters. This would be 12 centimeters. This distance would be 12 centimeters. And if the distance to the object is 12 centimeters, distance to the image would be 12 centimeters. Okay. Distance to the image would be 12 centimeters. Okay. So distance to the object is 12 centimeters. Distance to the image is 12 centimeters. So these are the first two images. Okay. These are the first two images. Clear? This one and this one. So that's what they're asking. That's all. Okay. That's what they're asking. It's not a difficult question. Okay. It's not a difficult question. These are the locations of the two images. But I mean, I just need to mention, like, it's going to keep creating images, okay? They are going to keep creating images. You know that if you place two mirrors like this, it's going to be thousands of images, like, it's going to be thousands of images. Why? Now, after this, we have two images formed, okay? Now we have two images formed. After these two images, okay, after these two images, so actually, like, after schools, I mean, if you can come to the class maybe 15 or 20 minutes late, maybe come to the class tomorrow. It's Tuesday, right? Yeah, come to the class tomorrow. So tomorrow we'll discuss based on that. So in the first 15 minutes, I'll do some questions or something like that. That won't affect for anything after that. So come to the class tomorrow, maybe at least, or join online, maybe at least 15 or 20 minutes late, and just inform me the issues. Based on that, tomorrow we'll decide. Tomorrow we'll decide whether to shift the class time by 15 minutes or 30 minutes or what, okay? So tomorrow let's discuss that in the tomorrow physical class and online class. So after that, what would happen is this will be an object to this guy again, right? It's going to keep happening, okay? It's going to keep happening. That means this is the mirror, and this is the first image created by this mirror. Then this will be an object to this guy. This will be an object to this guy. And this one will create an image of this one. So it's going to keep happening, okay? It's going to keep happening, clear? And this one, it is the image created by this mirror, right? It is the image created by this mirror. It's going to be an object to this. Clear? And this mirror will create an image of this far away. Like that, it's going to keep happening. Thousands of images would appear, okay? Thousands of images would appear. If I show you, this, that's all they have asked in the question, but just to show things, if I show you the array diagram of such an image, if I show you the array diagram of such an image, it's going to be like this. It's going to be like this. The array diagram of an image like that would be like, take this. Let's take this. So rays go like this, then return like this. So when you extend it back like this, then one ray going like this will reflect back with the same angle, will reflect back with the same angle. Okay. Will reflect back with the same angle, theta and theta, and these two rays will meet here. That's how this image is created, right? That's how this image is created. Got the idea? And these two rays, this ray and this ray, after that will keep moving here, and this ray will keep moving to this mirror. This ray will keep moving to this mirror. Clear? Got the idea? These two rays looks like they started from here, right? See? These two rays looks like they started from here, okay? It looks like they started from here, and here they will reflect back, and here also they will reflect back, and this one together will create an image like this. Like this. See? And it's going to keep happening. It's going to keep happening. Got the idea? That's how more images are created, okay? That's how more images are created. Because it's going to keep bouncing back again and again. The rays would keep bouncing back again and again, creating thousands of images, okay? Got the idea? So that's how it works, okay? If you have to write or draw anything, quickly complete. No need, okay? No need of this, but I mean, if you need to write down any points, you can write. Read the next one, question 2. After that, read the next one, question 2. No, light cannot be considered as a vector, but there are ways of converting any physical quantity into a vector base using, there are some methods, but not here actually. So, and the main thing is, light is not a physical quantity like that. Light is a thing, not a physical quantity. Clear? Light is not a physical quantity, it is a thing. This pen is not a physical quantity. This pen is a thing. There are physical quantities that I can measure about this pen, like the mass, the length. Same goes with light. So asking whether light is a vector or not is not a valid question. Light is a thing. Okay? Just like this pen. There are some vectors we can measure about light, and some scalars we can measure about light. For an example, luminous intensity. Like that. There are physical quantities connected with light. Are these physical quantities vectors or not? Yes, that is a valid question. Clear? That's how it works. You can't ask whether this pen is a vector or not, because it's not a physical quantity, it's a thing. But other factors connected with this, the physical quantities connected with this, like the mass, the length, things like that, you can ask whether they are scalars or vectors. Okay, that's how it goes, because there's a question online. So, second question. After the third question, I asked you to try the second question. Okay, second question. What they are telling is a child 160 centimeters tall. There's a child 160 centimeters tall. 160 centimeters tall. And his eyes are located 10 centimeters from the head. Okay. So it's going to be like this. And head, the total height of the person is 160 centimeters. And eyes are located 10 centimeters from the head. Okay. Eyes are located 10 centimeters from the head. Now the mirror, now these eyes. So the thing is, what is the minimum size of the mirror to see the whole body? That is the question. So to see the whole body, whatever the rays going out from the body should enter the eye. Okay? Whatever the rays going out from the body should enter the eye. So in that case, whatever the optical ray going from the head after meeting the mirror should reflect back and meet the eye. Then you can see the head. Clear? If a ray going out from the head hit the mirror, returns back to the eye, then you're gonna see the head. Okay? So definitely the mirror should be here. Clear? Definitely the mirror should start here. Got the idea? Mirror should start here. Otherwise you can't see the head, right? Then after that, if we consider this line, okay, if we consider this line, a ray would go like this, then return back like this, then return back like this. Clear? Then only you can see the bottom, right? Then only you can see the bottom. If a ray moving from here reach the eye, so definitely the mirror should go until here to see the foot, right? That means the minimum length of the mirror is this. Got the idea? That means the minimum length of the mirror should be this. Clear? That's how it starts, okay? Then I can mark angles. How? Here. And here. Okay? I can mark angles. So if this is alpha, this would be alpha, reflection loss, right? Okay? If this is theta, this would be theta, again reflection loss. So according to this setup, you should understand that this triangle, pay attention, you can write things later. This triangle and this triangle are equal. This triangle and this triangle are equal, right? This triangle and this triangle are equal. This triangle and this triangle are equal. Clear? So, if this is x, again this is x. Clear? If this is y, this is y. Got the idea? They are symmetric, right? Then what is the size of the mirror? This length is y. This length is x. Okay? Length of the mirror would be this length is y. This length is y, and this would be x. Got the idea? Got the idea? So, okay, clear? Got the idea? So, if this is y, and if this is x, this is going to be x. Clear? So the total height of the person is 2y plus 2x, right? See, according to this diagram, total height of the person is 2y plus 2x. Clear? Which is equal to 160 centimeters. Clear? Then y plus x would be 80 centimeters. Clear? Then y plus x would be 80 centimeters, which is the length of the mirror. Got the idea? So the length of the mirror should be half of the size of the person. Clear? So now this is the thing. We didn't use any new theory. All we used was reflection laws. That's why they are not asking us to teach anything in the teacher's guide. But still they can ask any question. Because no one can tell that I didn't know how to do this question. Why? From O levels, all the information required to do this question you learn from O levels, right? All the information, all the rules required to handle this question, you learn from O levels. Only the question is difficult, okay? So that is the nature here. So try question 4 now. Now you would be able to try question 4. Why? In question 4 now what they are telling is the eye is placed at the middle of the hole. And you have to see this wall. You need to see this wall. So now I think you can handle. It's a bit similar to this, okay? It's a bit similar to the same question, okay? It's going to be a bit similar to the same question. So what I need you to do is, do the same, just use the same concepts, okay? Just use the same concepts for this, okay? Try this quickly. Try the next one. Try the next one. Right. There's a question why 40 centimeters based on for which question? I didn't find any 40 in any question, right? And the third one. Okay. For the third one, we'll see. So today's main target is to be okay with reflection, okay? Be okay with reflection because there's nothing stopping the people who write paper, who make the paper. There's nothing stopping them from giving questions from reflection. That's why. So based on the same concept, now try question 4 maybe. There's a question, there's so much work. Yes, that's how it works. Okay, so how our class model works is like that. At the beginning, we do a lot of work. We start papers very soon, start paper discussions very fast, try to finish some additional lessons at the previous days. So like that, we go through a lot and somehow try to create a very large margin with other students at the beginning, okay? That's the easiest way to win A-levels. This is a competitive exam at the end of the day. So the easiest way to win is you create a large gap with everyone else at the beginning as fast as possible. You create a large gap with everyone else at the beginning and then you just have to keep that up. Then it's quite easy to do that, okay? Then you just have to hold that. Keep doing the same thing every week without any hurry. So at the beginning, we have to rush, we have to do a lot of work and we have to create a lead. Then it's just about keeping that lead, okay? That's how things work in A-levels. I don't know, that's how things work for us in A-levels. I hope it worked for all the other batches, so it should work for you, your batch too. Okay, next. Question 3. Next, question 3. Not the third one, right? We have to do question 4. Question 4 next. So in the fourth one, a man stands in a room so that his eyes are in the center of the room. Okay, so there's a large room like this. There's a large room like this. Okay. There's a large room like this. This wall is capital H. This wall is capital H. Okay. Then the eyes are placed at the exact center. Okay. So if the length of the hole is L over 2 and L over 2, if the eye is placed here, the ray would go like this, then like this, then the other ray should go like this and like this to make sure that we can see the wall behind, right? Okay. And it should follow all the theorems. It should follow all the theorems. Okay, got the idea? So now, next. Okay, so next what we have to do is, if this is theta, this is theta, this is theta, and this is theta. Now, I mean, the setup would be very symmetric, okay? Setup would be very symmetric, this part and this part, because the eyes are placed exactly at the midpoint, okay? Eyes are placed exactly at the midpoint. So here, I mean, we can tell I mean, this is not going to be this difficult, but I'll show you with proper maths and all. If this is x, if this is x, and if this is y, these diagrams are very symmetric. So this is also x, and this is also y. Okay, it doesn't look like that the way based on the way I drew the diagram, but that's how it is, right? It's going to be symmetric like this and symmetric like this. So this part, upper part, and the lower part would be symmetric, okay? The upper part and the lower part would be symmetric, okay? Then here, I mean, now this is the size of the mirror, right? This is the size of the mirror. Got the idea? This is the size of the mirror. Basically, it is 2x, right? See, this is x, and this is x. So size of the mirror is 2x, right? Size of the mirror would be 2x, okay? Then we have, I mean, you can use tan theta. I mean, you don't have to go through all this, okay? You don't have to go through all of this, because I mean, it's just like proportionality. You can just use the proportionality, but I'll show with proper steps, then it's easy to understand. So tan theta equals y over L, right? Clear? Tan theta here, according to this, tan theta equals y over L. Clear? Tan theta is y from this triangle, y over L, okay? Then from this triangle, tan theta is from this triangle, tan theta is x over L over 2, right? Clear? From this triangle, tan theta is x over L over 2, right? Clear? X divided by L over 2. Clear? X over L over 2. Got the idea? From this, it is y over L. From this triangle, it is x over L over 2, which means 2x over L, which means 2x over L, and this tan theta and this tan theta is equal. This tan theta and this tan theta is equal. Then y over L equals 2x over L. Y over L equals 2x over L. Then we can tell y equals 2x, right? We can tell y equals 2x. Okay. So then here y equals 2x, here y equals 2x. So this total capital H, equals what? This total capital H equals 2x plus x, 3x, 4x, 5x, 6x. Clear? So capital H equals 6 into x. Okay? 6 into x. So if 6x is h, 2x would be h over 3, right? 2x would be h over 3, and 2x is the size of the mirror, right? 2x is the size of the mirror. So height of the mirror is h over 3. Clear? Height of the mirror is h over 3. Just let me know if you need me to explain this again. Okay. So that's how it works. So height of the mirror would be h over 3. Clear? So that's how it works, okay? That's how it works. So the total height, capital H, the rays should go like this and like this, return into I. Then only you can see this whole wall. Then it should follow reflection laws. So to reflect this, the mirror should start here. To reflect this, mirror should start here. And if this part is x and this part is x, the height of the mirror is 2x. Let's take this as y and this as y. If this is x, this would be 2x. Okay. If this is x, this would be 2x. Y. It's the same theta. So here, this is x, which means this is x. So it's going to be tan theta equals x over L over 2. Tan theta is x over L over 2, x over L over 2. From this, tan theta is y over L. Tan theta is y over L. Okay. Tan theta means y over L. Then these two are equal. These two should be equal. So y over L equals here 2x over L. So y becomes 2x. which means I can write here 2x and here 2x. So this is 2x plus x, 3x, 4x, 6x. So the total height would be 6x equals h. Then 2x becomes h over 3. 2x is the height of the mirror because it starts here and ends here. Clear? Okay. So quickly try to do question 1 now. Quickly try to do question 1. It's an entirely different question. Okay. Question 1 is an entirely different question. Try that. Try question 1. Try question 1, an entirely different question, but I'll give you a method. Don't use relative velocities or anything like that. What is speed? Distance traveled per second. So just try to find the location of the image 1 second before. Then try to find the location of the image 1 second after. The gap between the image 1 second before and after would be the speed of the image. That would be the easiest way to handle question 1, right? Get the location of the image. Okay. Get the location of the image 1 second before. Get the location of the image 1 second after. Okay. Then use that. Just put messages in the chat if you need me to explain this again. Here it is x over, this length is L over 2 because it's half of the room. So this is x over L over 2. X over L over 2 it is. X over L over 2. Same tan theta. X over L over 2. X divided by this, which means half of L over 2. X divided by half of L over 2. You take these two up, it becomes 2x over L. Then here y and L. Y and the total length of the hole is L. So y over L. And it's the same tan theta. Why? It's same theta according to reflection laws. So these two are equal. So y over L equals 2x over L. Then L cancels out, y equals 2x. Then 2x equals h over 3. Okay. 2x equals h over 3. Okay. Y cannot be x. This part is only x. Clear? This is y. Same angle. Just do the maths, okay? Have to be a bit good at maths. So now what you are seeing is a later lesson, okay? So whatever you faced in units and dimensions, whatever you faced in measuring instruments, you won't see that level of primary stuff in upcoming lessons, okay? So we are doing an upcoming lesson. So you have to have the ability to understand a certain level of mathematics, have to maybe watch recordings again and again and try to understand things, okay? So the upcoming lessons are not going to be primary like the units and dimensions and the measuring instrument lessons, okay? So that's how the syllabus is built. Initially students are from O levels, so let's keep the more simplest lessons at the beginning. Units and dimensions and measuring instruments. Then let's start real physics. That's how things work in the syllabus, okay? So this is a lesson towards the middle. So you won't be able to just understand things like in units and dimensions and measuring instruments in these lessons, okay? You may have to try, okay? It's not going to be very direct, okay? There would be a certain level of mathematical complexity, a certain level of logic you may need to understand things. You may have to go through a lot of work to understand upcoming physics stuff. I mean, if the whole syllabus looks like the units and dimensions lesson and the measuring instruments lesson, 70% of the country won't fail, right? Okay, only 6% get an A because none of the lessons after this would look like the units and dimensions lesson and the measuring instruments lesson and the very easy physics you see in classes. No. Okay, physics gonna be difficult and you have to face that. You have to do a lot of work. Okay, that's the best message to learn by doing middle lessons at an early stage. That is a very good thing you learn. Why this is 2x? The ray have to move a larger distance from here to here, which increase this height. Then ray only have to move a shorter distance from here to here, which this will have a smaller length. So if this is x, this becomes 2x, because this ray have to move twice the distance than this. Because this is from this end of the wall to this end of the wall, but this is from this end of the wall to the middle of the building, to the middle of the room. So this one has to move twice the distance in this direction, which means this length would be twice as this. Twice as this. This one has to move twice the distance. So this length would be twice as this. Clear? Clear? This is x and this is 2x. See? This is x and this is 2x. That's why, because this one have to move a larger distance than this one. It's from this end to this and a very small distance like this. And the thing is, again, you can't tell that you didn't know how to do this question. Why? It's not using any complex physics. It's just reflection laws, right? The same reflection law you knew from O-level, okay? And y over L means this tan theta. Y over L means this tan theta from this triangle. Y over full length L. Full length is L. This full length is L. So y over L. Here it is x over L over 2. X over L over 2. This is x. This is L over 2. Tan theta. This is y and this full length is L. And these two tan thetas are equal. Okay. Got the idea? The students who asked the questions? The students who asked questions, did you understand this? Anyone else having any other questions? And here we are not doing any difficult physics, okay? Okay. So for that question, if I draw a proper diagram, for that, this is how it looks, okay? The rays, this is the point. The rays go like this, then like this. Zoom here. Then the rays go like this, then like this. So upper part and the bottom part would be very symmetric, okay? Upper part and the bottom part would be very symmetric. Clear? And this is the length of the mirror we need. This is the length of the mirror we need. Okay? This is the length of the mirror we need. And this length, when it is 2x, this length would be x. And at the same time, when this length is x, because the diagram is symmetric, this would be 2x. And as you see, height of the mirror would be 2x. Height of the mirror would be 2x. And height of the whole wall would be 2x, 2x, and this is also 2x. 2x. So it's going to be 6 into x equal to the height of the wall. So 2x would be h over 3, which is equal to the height of the mirror. 2x equals h over 3. That's how it works, okay? 2x equals h over 3. Okay. So I hope it's enough time to try question 1. We'll check that now. I was just explaining things again and again until others try question 1. So how can a mirror move? There's an answer. Imagine a mirror being chased. Good answer, by the way. So why it's theta and theta? It's the most simplest, thing you have to know. The reflection laws, okay? The reflection laws. Incident angle equals reflected angle. Incident angle equals reflected angle. That's why it's theta and theta, okay? Incident angle equals reflected angle. Incident angle equals reflected angle. The angles should be equal. That is reflection laws. There's a mirror. So what happens here is a reflection. So the theta values would be equal, okay? All the theta values would be equal. That's how reflection works, okay? And this part and this half are entirely symmetric because the eye is placed exactly at the middle. So the upper part, whatever happening at the upper part, should be equal to the bottom part because eye is at the exact center. So this part, this half are symmetric, okay? So the next one, there's a question for the first one. How can we find the initial distance between the mirror and the object? You can't, so let's consider that as L. So read this question, the first one. So there's a mirror. So the question is, there's a mirror. There's a mirror. Object moves at a speed of 5 towards the plane mirror. Object moves at a speed of 5 towards the mirror. And at the same time, the mirror is moving with a velocity of 1. At the same time, the mirror is moving at a velocity of 1. What would be the speed of the image? So the easiest way is, what is speed? Distance traveled in 1 second. Speed means the distance traveled in 1 second. Okay? So let's consider 1 second. That's all we have to do. That means this is the mirror. So pay attention properly. Don't try to write in the middle then ask questions. So pay attention properly. So initially, this is the location of the object, okay? Let's take the distance as L. Let's take the distance as L. Then the image will be formed at a similar distance L. Image will be formed at a similar distance L. Clear? Then the object moves within a second. Within 1 second, the velocity of the object is 5 meters per second. That means within 1 second, this guy will move 5 meters, right? This guy will move 5 meters. Clear? That means this is the new location of the object. Okay? Then within a second, the mirror would move 1 meter. The mirror would move 1 meter. Why? The velocity of the mirror is 1 meters per second. So So this would be the new location of the mirror. Clear? This would be the new location of the mirror. Got the idea? So now it's gonna be, what is the new distance between the object and the mirror after 1 second? After 1 second, what is the new distance? It is, this is L. I'll explain this again. Okay, I'll finish it once and I'll explain that again. This is L and this is 5. Okay, then this would be, what is this? If this is L and this is 5, this would be L minus 5. Clear? This is L minus 5 and this is 1. This is L minus 5 and this is 1. So L minus 5 plus 1, it would be L minus 4. So this new distance is L minus 4. Clear? Zoom this. So when the object is placed at a distance of L minus 4 from the mirror, image will be formed at a similar distance of L minus 4, right? Image will be formed at a similar distance of L minus 4. So this would be the new location of the image. Okay, this would be the new location of the image. Okay, so now this is the distance. This is the distance traveled. This is the distance traveled by the image within 1 second, right? That's what I need to find. That's what I need to find. This is the distance traveled by the image within 1 second. Got the idea? So there I can get, this is L and this is 1. So this would be L minus 1. This is L and this is 1. So this would be L minus 1. Okay. So L minus 1 equals what? L minus 1 equals what? This plus this, right? L minus 4 plus y. Okay. So L cancels out. Then here you have minus 1. I'll take this minus 4 to this side, which becomes 4 equals y. So according to this, y becomes 3. That means within a second the image moved by 3 meters. So the velocity of the image would be 3 meters per second. Okay. Velocity of the image would be 3 meters per second. Got the idea? That's how it works. Just now pause the questions. I'll explain this again. So again, joining a fast track, one of the best things about joining a fast track is you figure out things are not going to be easy when you move forward. Okay. The previous days you just see units and dimensions and measuring instruments. So that's why I even started that 6:30, 7:30 additional session for you guys to do difficult questions. You should see what comes in the future. Okay. Based on that, you have to start working. Okay. The intelligence level you have now may not be enough. Okay. The level of thinking you can at the moment won't be enough. So start working on your intelligence level. Start working on things that you can't understand. That's why we started that 6:30, 7:30 additional session to improve thinking. Just fight with what you can't understand. Okay. Because in units and dimensions, measuring instruments and previous days, the theory was not difficult, and only the very difficult questions I find would be difficult. But here, even the general questions become difficult, okay, when you move forward in the syllabus, okay. Okay, so that you have to understand, okay. The more you move forward, the intelligence level you currently have from all levels won't be sufficient. So you have to fight back, okay. You have to fight back. You have to keep thinking, okay. I'm not going to dilute this to because this is the upcoming lesson. So I'm not going to dilute this to a level of a O-level student. You try to become an A-level student, okay. So if I show you the maths again, what we used, I just took the initial distance, but this is the most difficult questions in A-levels you can get from reflection. Nothing more than this, okay? Nothing more than this. That's why I said I'm not going to do a lot of stuff from reflection. I'm just going to show you the most difficult questions you can see and move forward. Because this is not basically in the teacher's guide. But these are the most difficult questions you would find in from reflection. So the location of the mirror currently here, location of the object is L. There's only one rule we know about mirrors, that is the object distance equals the distance to the image. So if the distance between the mirror and the object is L, the distance between the mirror and the image would be L. Then you have the object. Its velocity is 5 meters per second. That means it has to move 5 meters within a second. Then the velocity of the mirror is 1 meters per second. That means the mirror would move 1 meter within a second. Then the new location of the object would be this. Not L, it's going to be this. And the mirror would move by 1. So this is L, this is 5, this is L minus 5, and the mirror moved by 1. Total, it's going to be L minus 5 plus 1 would be L minus 4. L minus 5 plus 1 would be what? L minus 4. And from this to the image, it is again L minus 4, okay? From this to the image, again it is L minus 4. Why? From the mirror, distance to the object equals distance to the image. Okay. Now, this was the previous location of the image. Distance L from this. This is the new location of the image. Distance L minus 4 from this. This gap is the distance moved by the image, which is, this is L, this is 1, so this becomes L minus 1. This is L minus 4, so distance to the object equals distance to the image, so this is L minus 4 and this is Y. So from here to here it is L minus 1 equals L minus 4 plus Y. Okay. Then L cancels out, you take this 4 to this side, 4 minus 1 equals Y, which means Y equals 3. That means within a second, image moved by 3 meters. So the velocity of the image is 3 meters per second. Okay. Velocity of the image is 3 meters per second. Did you understand this? Put a message. Anyone? Any further questions? Y is the distance traveled by the image. within a second. Why did I took the initial length as L? Because they didn't give that, okay? They don't have to give everything, okay? Clear? Initial distance is L. It wasn't given, yes. So you just put that, okay? Then later things would cancel out and you would get the answer. So the basic thing you should understand is it's not O levels anymore, okay? It's not O levels anymore. They don't give you a bunch of values. Then you just don't put the values here and there and get the answer. It's not like that, okay? So the basic idea is it's not O levels anymore. So that is the fundamental thing we should understand, okay? Clear? When we are doing units and dimensions and measuring instruments, you would feel, okay, it's cool. It's like O levels again. But it's not going to be like that anymore in mechanics, in optics, in fields, in matter and radiation, properties of matter. So all the upcoming lessons would be difficult, okay? So that's the nature of A levels, okay? So it's good for you guys to figure that out at an earlier stage by joining a fast track, okay? But if you find this difficult, it's all okay. Why? We'll do mechanics. Then when we are doing mechanics, your intelligence will improve. Your speed will keep improving. Then when it is the proper time to do optics, you would understand the Sysygy. That's how the syllabus is designed, okay? So at the moment, you may not be able, no, I mean, you have to understand this. At the moment, many students are not able to get this answer without my help, right? But this is the first set of questions from optics. So how can that happen? The first set of questions from a lesson you can't do alone. The reason is this lesson comes very late, okay? So by then, as a result of struggling through mechanics, your intelligence will improve, your thinking speed will improve, and after going through all of that, when it is the correct time for optics, you would actually have the ability to understand this directly without my help, okay? That's how A-level syllabus is designed, okay? So you would struggle a lot when we are doing mechanics. With that, your intelligence will improve. Then after that comes the optics lesson. Then by that day, when all of a sudden you see these questions, you quickly get the answer. Everyone, okay? Everyone. Okay? That means your intelligence will be improved by then. Your thinking ability and everything will be improved by then, okay? For that, you have to go through a very rough road, okay? So otherwise you may think, okay, I mean, the optics going to be really difficult and everything will be really difficult. I can't get answers for anything directly. Yes, because you are not up to that standards yet, okay? When you go through the A-level syllabus, your intelligence improves. So when it is the correct time for optics, when we do optics, you all of a sudden understand things, okay? That's how it happens. You may not believe that now. You may not believe that you can do these kind of questions easily without my help. But when we are done with mechanics, you would have that ability, okay? Trust me. For now, all you can do is trusting me, right? What else? Okay, let's move forward a bit, okay? Let's move forward a bit. Did you understand? The students who ask questions, quickly post. You have any questions remaining? No, this doesn't come under thermal physics. It's before that. Anyone? Quickly. How to figure out a diagram to handle the question easily? Just after finishing mechanics, you would have that ability because we draw like millions of images and diagrams in the mechanics lesson. Quickly. Everyone quickly post in the live chat and the Zoom chat. Did you understand everything? If you did understand, just put a message quickly. YouTube live students. Okay, let's move forward. Okay, let's move forward. So the next topic, so we are done with reflection. So don't worry a lot about reflection and all, because it's not in the teacher's guide. The questions I showed are the most difficult questions that you can ever get from reflection, because they can't give more difficult questions than this from an area which is not included in the teacher's guide. Okay, clear? So no worries about that. Okay, they are not going to give more difficult questions from an area which is not in the teacher's guide. Okay, so let's move forward. Now only we start the material of optics in A levels. Okay, so reflection belongs to O levels. So our A level optics syllabus starts with refraction. Within the given time today, I would be able to do a rough explanation of refraction. Then we can cover the remaining part next week. So talking about refraction, it is energy, optical energy. Just post any questions regarding the previous stuff. I'll today explain things again if you need, and next week directly move to refraction. Okay, so refraction will be again explained next week. Today's according to my target, today was for optics. Next week, not today, was for reflection. Next week is for refraction. Since we have some time remaining, I'll do some stuff about refraction. So if this is a boundary, if energy reach this boundary, initially in reflection, it went back to the same side, but if falls to the other side, we call that refraction. Okay, and what you have to understand is there's no perfect reflection or refraction kind of stuff. Okay, that you have to understand. Okay, there's no perfect reflection or refraction kind of stuff. That means through any medium, what actually happens is a certain percentage of energy falls to the same side, a certain percentage of energy falls to the other side. Okay, what actually happens is a certain percentage of energy falls to the same side, a certain percentage of energy falls to the other side. That's how it works. Okay, so as a result, like in any refraction scenario, assume that 100% of energy reach here. In some scenarios, like 99% reflect, 1% refract, we call this a reflection. Okay, we call this a reflection. There's no perfect reflections. We call this a reflection because a majority of the energy reflects back. And this small part that refracts, we call that partial refraction. Okay, the small part we call partial refraction. Got the idea? Okay, next. Okay, we call this partial refraction. Next, now when energy reach a boundary, okay, if like 99% of the energy moves to this side and like 1% returns, we call this a refraction, and this part that reflects back, we call it partial reflection. So this is a reflection and a partial refraction. This is a refraction and a partial reflection. In both scenarios, the partial part is energy loss. Okay, in both scenarios, the partial part is energy loss. So whenever a reflection happens, whenever a refraction happens, we lose some energy. Okay, that's why when a glass faces direct sunlight, ideally the whole energy should move through the glass. but actually a certain amount of energy reflects, certain amount of energy is absorbed. As a result, the temperature of the glass goes up, right? See, it is the same energy, right? If 100% of light energy moves through a window, windows can't increase the temperature. But actually, if you touch a glass under direct sunlight, its temperature is a bit higher, right? Why? Due to these different types of energy losses, okay? It's due to these different types of energy losses. Some partially reflects back, some energy is absorbed by the glass, okay? So different things happens to this optical energy that reach this boundary, okay? Clear? So that's what we have to discuss in the next day's lesson, refraction. So next week what we are going to do is we are going to learn the refraction laws. You already had these things in O levels. What are the refraction laws? Roughly mentioning this perpendicular line and this are on the same plane, and you had something called I, R, and N equals sin I over sin R. This you had in O levels, right? Okay. Yes, right? The same, exact same thing. What did you call this? The Snell law, right? Snell law, did you use that term? The Snell law? No. Some yes, some not. Is that the case? Snell law? You have heard? Yes? The term was there in the O-level book, right? So so don't worry about refraction. We are not going to get anything from O-levels. We are going to learn everything from beginning, even the definition of refractive index. Snell law, everything will be changed. Everything will be changed from what you learned in O-levels, okay? So no worries about refraction. It's going to be entirely new, okay? So just again, online students, for any information, contact this number, join the group, set up the website and all. Note 76663851. So now tomorrow you have your normal class. We are starting motion graphs part, first part of mechanics, okay? And there are some questions about weekly papers will be answered in the groups, okay? Yeah, marks of the weekly papers, how you get them, everything will be informed tomorrow in the class, okay? So everything will be informed. So yep, that's all for today. You don't have to do anything, just go through the lesson again. The lesson is anyways available, since it is the first day, it's available in YouTube. From next week you have to join from the website, set up the website. And since it is available in the YouTube, just watch this again and again, try to understand the reflection part, because reflection part is the most difficult part to understand, because it is from O levels, so we are not going to do a lot in A levels, okay? Okay, so that's all for today. Let's meet tomorrow. Tomorrow you have your usual class. Then let's move forward with refraction next week. Thank you.